All right, so chapter 7 is only 4 sections long, but I divided it up into like kind of mini sections. So all of our lessons are really only going to be like 10 or 15 minutes every day, and then you guys are going to have some time to work on Math Excel. I also split the Math Excel to go along with the lessons that we're doing in class each day. So when you look on Math Excel, yes, there are 3 7-1 homeworks, but there's a 7-1 day 1, which is what you can do after today's lesson, a 7-1 day 2, a 7-1 day 3, and they're all due on Thursday night. But ideally, you should really just probably be getting them done as we do them each day, like normal homework assignments, okay? The lessons are all about hypothesis testing. So this is kind of a culmination of all the things that we've done so far, calculating a z-score and testing data or statistics to see if a certain result, like, or a certain claim, like Mr. Z's claim about his zippers in your activity yesterday, is true or false, and use statistics to actually determine that. Yes?
There's like correlational testing. Correlation.
We'll talk about correlation a little bit later. We won't use correlation for these problems. So that'll be in chapter 9. We do like a couple sections out of that, but we will get to that. Yep. Okay, so 7-1, we won't actually really be doing any of the actual hypothesis testing. These are kind of like the building blocks that you need for when we get to 7-2, when we start putting it all together and actually doing a hypothesis test. All right, so a couple things that we need to know or review to start. So we did not do section 6.3. That's not part of our syllabus, but it is going to pop up a little bit just as far as like the label goes, so you need to be aware of it. So P is a population proportion. And so it's essentially a percentage. So P might say 63% of the population likes math, okay? And that might be our data statistic that we have. P hat is what we call it, has the little kind of caret above it there, is the point estimate for that. So it's the sample proportion. Okay. How we calculate a proportion is we take the number of successes that we have, x values, and divide it by the total. So back to that math example of 63% of the population likes math, 63 would be x, people that like math, and 100 would be the percent of the population. When we divide the two, we get that 63%. Okay, so P, you just need to remember, is a proportion for the population. P hat is a proportion for a sample. So you might see either of those variables pop up just in some of the hypothesis statements that we see, and I wanted you to know what that represents. Okay, we also calculate confidence intervals for population proportion. You guys really don't need to worry about that at this point. You can see it uses critical values of z, and we'll actually talk about it a little bit when we get to section 7.4 a little bit later on. Okay, we'll come back to this slide at that point. All right, so what is a hypothesis test? A hypothesis test is a process that uses sample statistics to test a claim about the population parameter. Okay, so we have some population parameter that we're looking to test a claim about. So it might be a mean population or of the population, or it might be a variance of the population, or it might be a standard deviation of the population, or it might be proportion to the population. So there's lots of different statistics we might have a claim about, and we use the sample statistic for that to test the claim that's being made. Today we're going to talk a lot about the different types of hypotheses and claims that can be made, so just kind of like setting up a hypothesis test. So definition at the bottom there in the bubble, this is a big idea here. So there are 2 hypotheses that will be in every hypothesis test that you create or solve or write or whatever you're having to do with it. There is a null hypothesis. For a null hypothesis, H sub 0 or H null is what we're going to use for that. And then an alternative hypothesis, H sub A, is the notation that we're going to use for that. The null hypothesis and the alternative hypothesis are opposites of one another. Between the two, it is going to have every possibility in it. So we're going to use a lot of less than, greater than, equal to statements. How you know which one is which? The null hypothesis will always be the one that contains some sort of equality in the statement. So less than or equal to, greater than or equal to, or just flat out equal to. Anything that's equal will be in the null hypothesis. And then the alternative hypothesis will be essentially the complement the opposite of that. So it'll be just strictly greater than, less than, or if it's equal to, the complement of that is not equal to. So null hypothesis, statement of equality. Alternative hypothesis, H sub A does not have a statement of equality, and they are complements of one another. Good. Okay. So looking at this slide, then I'm going to graph on a number line where these particular statements are located at, our hypotheses. Notice on each of these, it's labeling what the claim is. The claim is the statement that we are ultimately testing when we're doing hypothesis testing. The claim could be the null hypothesis, or it could be the alternative hypothesis. So when you start writing these, you will always be labeling what the null is, what the alternative is, which one is actually the claim that's being tested. Okay. All right, so the first one, I mentioned that P was going to show up. Here's an example of where the P shows up. So that 61, that 0.61 is 61% of something. Okay, so that null hypothesis, if I were going to put it into words, is that 61% of the population does X, Y, or Z, whatever that is. Okay, that's the claim that we're testing. It's equal to 61%. And the alternative hypothesis is that 61% of the population does not do X, Y, or Z, whatever our problem stands for. Okay, so graphing these. My null hypothesis is a statement of equality, and it for this one is just a single point, H sub 0. Okay. My alternative hypothesis is everything except that. So essentially my whole number line would be shaded except for an open circle of that single value. Okay. For the second one, we have a null hypothesis that a population mean is less than or equal to 18 years. Okay, so that might be like, I don't know, seniors in Jackson High School. We were saying that the population mean is less than or equal to 18 years. And the alternative is the claim. Somebody is trying to say maybe that the population mean of all seniors in Jackson High School is more than 18 years of age. Okay, if I'm going to graph this, starting again with that null hypothesis. So I'm going to find 18 wherever that is on my number line. Fill in my dot. And this one I can shade a little bit nicer. Looks something like that. Okay. And then my alternative would also start at 18, but it's strictly just greater than. So we have an open circle at 18 instead of a closed circle, not equal to. Okay. And then the last one, we have a null hypothesis that says the mean of, again, something is greater than or equal to 15 minutes, and the claim that's being made is that the mean is less than 15 minutes. Okay, so graphing that one. This time, start with my null again, 15, wherever that is on my number line, fill it in, and it would be shaded to the right. 0. And then my alternative hypothesis, the complement of that, would be an open circle, this time shaded to the left. Okay, so you can kind of get a picture of where those regions are. Eventually, we'll be converting these values to z-scores and putting them on a normal curve, and we'll be shading our normal curve like we did before, between two values or to the right or to the left, instead of actually being on a number line. So we'll kind of get to that later. Questions on any of this? Yes.
So why is the HO have like a built-in dot compared to HA?
So, well, you can see in the statement we've got equal to on each of those. So anytime you're equal to on a number line when you're shading like back from inequalities, it's always going to be a filled-in dot. Or if you did like college algebra, it was like we used brackets and parentheses instead. But we're back to like with this, just what you did in Algebra 1, with the filled-in dot is equal to, the open circle is not equal to. Okay. Any other questions on this? All right, so statements below represent a claim that is being made. We're going to write its complement and state which is the null and which is the alternative. Okay, so the first statement that's being made, I see that lowercase sigma squared, remember that means variance. So the claim is that the variance is greater than or equal to 1.2. I'm going to label it as the claim. All these are the claim. Is this the null or the alternative hypothesis? How do you know? Because it's equal to. Good. Okay, the alternative hypothesis is the complement of this. It's still a claim of some kind about the variance, so we still are going to use that same variable. But what's the complement or the opposite of being greater than or equal to? The other one. Points the other way. Is it going to be equal to or no?
No.
Right, we're just going to use less than 1.2. And that's it. Okay. The next one is a statement that's being made about standard deviation if it's not squared. Okay. Is this the null or the alternative? This is the alternative. Because it's not equal to. So that means I need to write the null hypothesis. What's the null? The standard deviation is equal to 5. Good. Okay. And then last one. Is this the null, this claim, the null or the alternative? This is the alternative again, because it's not equal to. So the null hypothesis is that our population proportion is what? What's the complement of being less than 0.45? Points the other way? And equal to? Greater than or equal to? 0.45.
Okay, wait, is that one less than or greater?
So the one on the top there for the last one is less than. The one on the bottom is greater than. Alligator mouth opens up towards the bigger one. So the bottom one, because the alligator's eating pee, it's saying pee is greater than.
Oh,
If you're an alligator, you're going to eat the bigger guy, right? If you have two choices. All right. Yeah?
I never got that.
Never understood it.
Okay. Well, he's eating the pea on the bottom one, right? But he's not eating it on the top one. So that means on the bottom one, it's saying p is greater than.
Well,
On the
like,
bottom
what
one.
happens when there's two numbers? Like, what happens when there's two numbers? And like, is one not even like one? Like,
So they're all, the alligators are always pointing in the same direction if there's two numbers. So they're still always eating the bigger number. Okay.
I explode my brain.
Sorry. All right. This more or less you guys just really need to write down. I'm gonna remove these little buttons here. There we go. Okay. So we are gonna over and over again with hypothesis testing see these three sets of statements essentially that are being made. This will be in Polaris too if you want to capture it, I guess. But the wording is what we're going to have to be very careful about. So the top one is where we have a null that is greater than or equal to and an alternative that is less than. Remember, the claim that's being made really could be either one. So you might see this in your statement if it's talking about the null hypothesis. So greater than or equal to, at least means greater than or equal to, not less than means greater than or equal to, not shorter than means greater than or equal to. Or if they're making a claim that's the alternative, you might see this wording, less than, below, fewer than, shorter than. Those are all just less than statements. So a lot of these statements on the far left and the far right of the screen, guys, these are things that you guys saw back in Algebra 1 when you were writing just inequality statements. Now they're coming back up again because we're using inequalities in our hypothesis testing. Okay. And then you're going to see the opposite in that second row. Again, it's greater than, less than, it's just flipped. And then statements of equality versus non-equality, I guess. Equal to, exactly the same as, not changed from. So I'll give you guys a minute to get some of those important statements written down because you're going to want to be looking for those. A lot of the things that we're going to be seeing are word problems. You want to kind of hone in on these key phrases because that's going to tell you how to set up your null and your alternative hypothesis. And I know it seems like we're going kind of like really slow through this, but if you cannot set up the null and the alternative hypothesis correctly, the rest of your hypothesis testing will be wrong. So it's vital that we understand all the little intricacies here, because the rest of our problems are going to rely on that. Okay, so I'll give you a minute on that.
I have a question about the activity.
Yes.
For the Mr. Z question,
Uh-huh.
let's like add up all of these and use the mean that we.
Okay. I just have one more slide, I think. Is there just one more slide on yours?
Yeah.
Yeah, okay. All right, so last thing we're going to do is we're going to have a phrase that represents the claim, and we're going to write the null and the alternative hypothesis that goes with it. All right, so first one, a consumer analyst reports that the mean life of a certain type of automobile is not 74 months. Okay, so for each one, we're going to write null and alternative, and which is the claim. So I'm going to start with the claim. The claim says something is not. So what mathematical symbol are we going to use?
Equal to / out.
Not equal to. If it's not equal to, is it the alternative or the null? The ha. The claim is the alternative. And the claim that's being made is about the mean. Okay, so when you write it, it's going to be your symbol for population mean. It's always for population, not equal to 74, and I'll label it months. Okay, which means we still need to write the null. The null is also about the mean, and the complement of not equal to is equal to 74 months. Okay, that's it. All right, second one. An electronics manufacturer publishes that the variance of the life of its home theater systems is less than or equal to 2.7. Okay, so the claim that's being made, is it the null or the alternative? I don't know how I feel about that. The null. And it's for variance, which the symbol for that is our sigma squared. Okay?
Does not mean.
And it's less than or equal to. Yep, there you go. Whatever works. Less than or equal to 2.7. It didn't say what. I'm going to say years, because it's the lifespan of home theater systems. Okay, so then what's the alternative? That the variance is greater than 2.7 years. All right, last one. A realtor publicizes that the proportion of homeowners who feel their house is too small for their family is more than 24%. Okay, so the claim, is it going to be the null or the alternative? It is the alternative, because it says is more than, doesn't say equal to, so it's strictly a greater than statement. 24%, now usually we're going to write this as a decimal when we do proportions, 0.24, and again our population symbol for proportion is a p. So then the null, what's the complement of that p is, let's try to use a mathematical statement, less than or equal to 0.24. Okay, and then we're going to stop for today. Okay, so to be continued tomorrow. Like I said, you guys can do that first Math Excel assignment, and look, there are no calculations we did in any of this. Okay, it's just going to be a lot of drop down and fill-ins for this, so it should be relatively quick. Okay, I'll do cell phone lotto last 10 minutes or so are yours here. Cell phone lotto winner is 13 today. Nobody. You may grab your phone.